Welcome. In this video, I will show you how Quicksort works. Quicksort is a sorting algorithm that uses recursive functions, which means the function that calls itself. So let's say we have the input list unsorted. What Quicksort is trying to do is to get one element sorted at a time. So suppose we always choose the last element. We will call this a pivot. So what it's trying to do is to put the pivot in the correct position, in the final sorted position. So the way it does this is to use the pivot to divide the remaining list into two groups, less than pivot and more than pivot. So let's say we have pivot here. We can use it to divide the original list into less than group and the more than the greater than a pivot group. The way we do this is we can just iterate every array and put it in less than and more than group. So as you can see, this process puts the pivot in the correct position, but everything is not already sorted yet, right? We just put one element sorted. So now we can just to make everything sorted, we have to sort it the left and the right side. So we can just use the same function, Quicksort, on the left hand side and the right hand side group. And finally, we can concatenate everything together and return it out. So now everything is sorted. So as you can see, why it works is that it divides the problem into smaller problems. The original list is divided into two smaller lists, and one element is put in the correct position at a time. So something is solved at each function call. So this will repeat the same process with the smaller list. It will pick the pivot, divide to greater than and less than group, and it will repeat the whole process until there's nothing left. It will return back into the caller function. Then in the end, we can return the sorted list where everything is sorted. So let's try it on actual numbers. First, we will pick the pivot in the last element, which is 3, and find less than group, which is 1 and 2. And the more than group is 6, 5, and 4. So now 3 is already in the correct position. So next we only have to sort these two smaller lists. We can do that by using the same function. Repeat the same process again. We call Quicksort on this and this one. So let's try it. Then we can pick a pivot as 2, less than group is only 1. There's nothing here in the more than greater than group. So now we reach the edge cases where there's only one element. So we can, when Quicksort encounters only one element in the list, we can just return that list and call it sorted. The same way, when we encounter the empty list, we can just return the empty list. So now everything is already sorted. We can return it to the caller function. So now we will replace here with sorted list, which is 1 and 2. Now let's try it on this side. We can pick 4 as a pivot. Less than group, there's nothing less than 4. 6 and 5 are in greater than group. Now we repeat the Quicksort on the 6 and 5 because this is done. There's nothing here. We can pick 5 as pivot. And there's nothing less than 5. There's only 6 left. Now there's one element left. It's done. Empty list. It's done. Now this list is sorted. We return back here. Replace it with 5 and 6. And everything here is now sorted. 4, 5, 6. We can return back here to the caller function with 4, 5, and 6. So now we done evaluate everything. We can return this list back which everything is sorted. We return back and now it's done. Thank you.